All right, guys, we're going to record things a little bit differently, and hopefully you can read my writing a little bit better. Now, we're going to be going through calculations that you're going to be doing all year long. So I don't want you to think that you need to learn these for just unit one, and this is the only time you're going to be tested on it. You're going to have to be doing calculations on every unit test. So we're going to go through some common ones that we do in many units. For many labs, you're going to have to determine and calculate rate. Now, when you think about rate, I want you to think of speed. Now, let's start with something that makes sense or familiar to you guys. You drive to school, and let's say that you went 30 miles per hour. See how you have a change in miles over your change in time. And that will maybe help you remember this formula for rate. Yes, it's on your formula sheet. It's right here, okay? You can see it's the change or delta. That's what that D means. Means change in Y or change in something over my change in time. Notice that that T means time on the bottom, okay? Now, back to this. So we're going to have a change. That delta means change in something over a change in time. Now, the way that I'm going to show you to do this is the easiest way, and it's going to help eliminate silly mistakes that you might make that's going to cost you a point, okay? So, for example, it says, calculate the average growth rate in millimeters per day is between 3 and 8. So when I read this, I basically see calculate rate. So I know that when I do this calculation, I need to have some numbers on the bottom that are an indicator of time. So it says calculate the rate between 3 and 8 days. So what I want you to do is I want you to put 3 days on the bottom to 8 days. That's my change in time. Yes, I know it's 5 days, but if you write it like this, when we do more complex problems with rate that you can't do in your head, you're not going to make silly mistakes. Now, how you figure out what number goes on top is all you have to do is you have to find the data point off of this y-axis for 3 days. So it says the growth rate between 3 and 8 days in a culture for the hair treated with this chemical. So at day 3, when this chemical is being used, it looks like the hair length is 0.5 millimeters. This is important. So right above 3, from reading the graph, I see it's 0.5 millimeters is the length of the hair. And now we got to figure out that same data, but for 8 days. So come over here for 8 days, go up to this data point that goes with the FGF5 treatment, come over here, and that would be 1.1 millimeters. And this is how you can tell if you're doing rate correctly. You should have units on top that are not the same as the units on the bottom, and the units on the bottom should be time. Okay, now let's go ahead and do simple math here. So when you subtract the top number, negative 0.6 is what you get when you take 0.5 minus 1.1 millimeters. You need to write units, and I'll talk why here in a second. And then on the bottom, 3 minus 8 is negative 5 days. Whenever you solve, that should give us 0.12. Now, this is how we write units. And if you're working this problem like on an essay question and you come up with 0.112 and you don't put the units, you're not going to get a single point. So it's important that you keep your units. And then now you have your units right here. You already know what to write. You just leave it exactly like this. It's millimeter over day. Millimeter over day. And if you look, that's what it was asking you to calculate is millimeters, change in millimeters over time. Now, one thing I want to point out, when you see calculate rate, if they say calculate the average, it's the exact same thing. I want you to put an X through the word average there, and I want you to write ignore it. Because whenever it asks you to calculate average rate, that word average really messes some of you up and you start doing math I've never seen before, okay? So no matter if I'm saying calculate average rate or calculate rate, you're going to do these problems the exact same way, okay? All right, now, you have probably been taught in your math class that rate really is equal to the slope of the line. And to calculate slope, it's the change in y over the change in x. So change in millimeters off of the y divided by my change in time off of the x. So when you're looking at table like this that has a change in something over time, what I mean by that is when I say over time, that means time is on the x-axis. Oh, this is over time. Then the slope of the line tells you how fast, in this case, the hair is growing. So if you have a steep slope, the hair grew really fast during that time. If you have less of a slope, it's growing, but it's not growing as fast. Okay. If you have a flat line, and now just to demonstrate this, I'm actually going to take this box and move it down. And let's pretend that the slope is 0. There is no change here. Okay. So make that a flat line. Then at this time, what this means is between day 7 and day 8, there was no growth. The rate of growth is 0. There's 0 growth. Okay. So again, changing something over time, you can tell how fast or the speed at which something is occurring by studying the slope of the line. Okay. All right. So I just wanted to indicate that down here because let me show you how they're going to take what can be a pretty easy problem. Like this seems pretty easy, changing something over the change in time, and they're going to make it a little more complex. And this is going to help them separate the people that are going to get 3s on the test to the people that are going to get 4s because they know a little bit more than just doing some basic math here. So let's indicate if there is a high rate of increase, okay, so there's a high rate, you're going to have a more steep line. Here we have a rate of increase, but the slope is less. So something's increasing, just not as fast. If we see a line going down, that means that it's decreasing at a high rate. Okay, so this is a high negative slope. It's going down. This, we have a decrease, but it's not, or it's happening at a slower rate, okay? And if anywhere we have a line, again, these are all between data points. So if I want to go ahead and put data points on here so they kind of look like what's up here, so you understand, we're just connecting points and we're looking at the slope of the line. So here, my slope is 0, rate equals 0, okay? So that means if this is like a reaction, the reaction is stopped. It's no longer happening during that time. Or here, my hair is not growing, okay? It stopped during day 7 and day 8. No more growth has occurred, okay? All right. Now that we understand that the slope, the steepness of the line gives an indication of rate. It says, calculate the rate of change for hair receiving no treatment during the time that growth rate was the highest. So notice they're not giving us the 2 times. You're going to go figure out the 2 times. And you have to understand this in order to figure out what numbers you're going to use here in your calculation. So if you look up here, do you see that for our no treatment line, see how steep it is right here between 3 and 4? That is whenever our hair is lengthening the fastest, okay? So those are our 2 times, 3 and 4. So let's do it the exact same way. So we're going to write 3 days to 4 days, okay? So let's take a look at the corresponding length in millimeters that goes with 3 days. So 3 days, go up here, and let's figure out, let's call that, I think we can call that 0.6 millimeters. And then at 4 days, okay, it's not quite at the 1, so do not call it 1. Okay, let's call it 0.95. We want to be as specific as possible, okay? So when we do the math, this is negative 0.35 millimeters over, my change here is negative 1 days. When you have a negative divided by a negative, you're going to see that we end up with a positive. And so my answer is 0.35 millimeters per 1 day, or you can just say per day. Okay. All right, let's see how else they're going to make rate trickier because this is too easy to put on an AP test, right? All right, so let's go down to this example. It says calculate the average growth rate. Again, we see the word average. We're not going to do all kinds of crazy math. We need to ignore that, okay? So the average growth rate in cells per milliliter per hour. Sometimes they do this and it can confuse students. Don't let it confuse you. I'm going to show you how the answer you're going to get, this is the units that you're going to see when you write your answer. Of the bacterial population between hours 2 and 4. Well, we got our time, right? Stick it on the bottom. So let's do that. So let's write 2 hours to 4 hours. Okay, and then now we're going to read our table. So it looks like it says bacteria population. Bacteria population is this line. So we're going to look at this line and ignore those dashed ones. See how they put a bunch of extra information on there that you have to learn to ignore. It's there to confuse you. So we don't want it to confuse us. So let's take a look at our 2-hour mark. So here's hours. This would be 2 right here. Okay. So let's take a look at our bacteria population size. And this is where it's going to be a little bit confusing for some of you. You got to know some math. 10 to the first power is 10. So at 2 hours, my bacteria population is 10 cells per milliliter. So I'm going to write 10 cells. Keep your units. Exactly what's right here. Cells per milliliter. So write cells per milliliter. Okay. And then let's go to the 4-hour mark and look up the data. So here, we're going to go up here to this line right here. Come on over. Now, what's 10 to the 4th? Well, this is 10. This is 100. This is 1,000. So 10 times itself 4 times is going to be 10,000. So 10,000. And again, it's cells per milliliter. Okay. All right, let's go ahead and solve that. So we would have negative 9990 cells per milliliter over negative 2 hours. We do that math again, 2 negatives. We're going to end up with a positive number. That equals 4,995. Now watch how we do our units. We can write cells per milliliter sorry, I'm running out of room there. My bottom part is hours. Now, if you're like, these units don't look like this, actually, it's the exact same thing. So the fact that this is on the bottom of this line and this is on the bottom, you can actually also rewrite it like this. 4,995 cells, and these two are on the bottom. So you can actually put them both on the bottom. So you would write milliliters, and then you can put an X or a multiplication dot there, hours. Okay, that is exactly what we see here. Notice I didn't do this problem anywhere different than what I did up here. Okay, all right, moving on. We're still going to calculate rate, but we're going to be calculating rate from the table. Let's start simple and show you then how they're going to try to make it a little more complex to confuse some of you. So calculate the rate of reaction for the time between 0 and 80 seconds. We got our 2 times, so you know what to do. We're going to write 0. Let's make sure, 0 seconds. And then they want 80, right? So 80 seconds on the bottom. Let's figure out the corresponding values. All you got to do is read the table. So at 0, it looks like this amount of sodium was 320. So we're going to write 320. Let the units just move right on over with that number. Milligrams per liter minus. So at 80, it looks like it was 130. So let's write 130 milligrams per liter. Simple math, okay? So then we are going to have 190 is milligrams per liter. When you subtract those two at the top, and on the bottom, we have negative 80 seconds. And we end up with, in this case, a negative number. Because when you have a positive divided by a negative, you need to keep that negative. So what that means is, if we have a negative rate, which let's go ahead and solve that. So this is negative 2.3. You're going to write milligrams per liter per second. Okay, just leave it like it is, milligrams per liter per second. And what this means, the fact that it's negative, is that something's going down. Our amount of sodium chloride is actually decreasing as this reaction is taking place. It's getting used up, okay, until it's all gone. So if you have a negative number that results, you have to keep that negative number, okay? But you just don't get rid of it. All right, let's take a look at the next one. They're going to make it tricky. Calculate the growth rate for the 5-day period with the greatest growth rate. Well, they're not giving you your 2 times. You have to go and figure out over here the 2 numbers that you're going to use from this days column. We had the greatest growth rate. So we need to go see where there was a change in something, change in the chlorella. and there was a lot of change at a period of time. So when I look here, I'm like, okay, there's a big jump from here to here. Okay. This also seems to be a pretty big jump. So we just got to figure out where was there a greatest amount of change. And if you do a little bit of math here, you're going to see that this is going to be a greater change than from here to here. So this is a difference of 0.9, but this is over 1, okay? All right, so it looks like we had a lot of change between day 10 and day 15. So we're going to write that. So let's write 10 days and then 15 days. Now we're going to get the corresponding values. So at day 10, now one thing I want to point out is we've got this unit here, and that can mess people up a little bit, but let me show you. You're just going to use this like a unit and leave all these numbers the same. You don't need to take 0.55 and times it times 10 to the 6th power and then write a big number there, okay? So I'm just going to write, here's my 10 days, here's that value. And by the way, these other ones, we know what those mean now. Those are the standard error values. And I really just am ignoring them right now. I know this is the average concentration, and that's what I'm dealing with, okay? So at 10 days, we're going to write 0.55 units. So you can write units is times 10 to the 6th per milliliter, okay? Minus at 15 days, 1.9. My units is times 10 to the 6th per milliliter. Okay. So when we do that math, we've got negative 1.37. Leave those units times 10 to the 6th per milliliter over negative 5 days. Okay. And then my final answer here, whenever I solve that, is 0.274 times 10 to the 6th. You can write per milliliter. You can write per milliliter. It's fine. And then this was on top. Days is on the bottom. Okay, it's as easy as that. So here's my answer, 0.27. Okay. All right. Let's try this one and see if we can not be tricked by the second step they're kind of wanting us to do here. Calculate the rate of growth per week in section 2 from day 14 to day 21. Okay. All right. Well, we see this and we're like, okay, it's rate. We got 2 days, right? So let's do that. Let's write 14 days on the bottom and 21 days on the bottom. Okay. And let's put our corresponding values. It looks like we're looking at mass of grass. So at my 14 days, the mass was 5.1 gram, 5.1 gram. And then for section 2 is what they want. So it looks like after another week, you can see that mass went up, okay? And so we have at 21 days, I'm sorry, the mass went up. The mass is all the way up to 9.6 now. So let's write 9.6, 9.6 grams. Okay, now, if we do this math, okay, so we would get negative 4.5 grams on top. We would get 7 days, negative 7 days on the bottom. And when we get done, we would have an answer that is gram per day. But that's not what it's wanting. It wants grams per week, okay? So if you would have done negative 4.5 divided by negative 7, you would have gotten a number here, grams per days. You would have missed that problem, okay? So really what this is we have negative 4.5 grams. 7 days is also equal to 1 week. And that's my answer. So when I simplify, we have a increase when we do a negative divided by negative. So it was 4.5 grams per, what's on the bottom is week. That's my answer. All right. Moving on, something different now. Let's take a look at percent, okay? Now, there is no formula on your formula sheet for percent. So you need to remember that when we calculate percent, oftentimes you're going to have a small number on the top, and that's called the part, and you divide it by the whole. Now, my generation is really good at calculating percent because all of our grades were reported as a percent. So when we got a test back, okay, let's say that we saw this written on our test. We had 10 over 20. That's what our teachers would have written on the top of our test. And what that means is we had 10 questions that we got right, and the whole test had 20 questions on it. So if we did this math, we would get a decimal of 0.5, okay? And that's not our percent because we have to then take that and times it by 100%. And that would actually give us our number as a percent. So that's 50%. We got half the questions or 50% of the questions right. So notice part, the small number, divided by the whole test had 20 questions on it, okay? So let's add up here for our equation, part divided by whole, but don't forget to times by 100, okay? And that's gonna give us our percent. Now, whenever I give you guys practices and I ask you to calculate percent, because we have a fraction, like we just dealt with rate, some of you will start to do rate when I'm asking you to calculate percent. So here's maybe something to help you remember. So rate is like miles per hour. Again, we were supposed to have time on the bottom. All these problems had time on the bottom, okay? So if you have something and you have like units like millimeters and you have time on the bottom, you're not calculating percent, you're doing rate. How you can tell that you're doing percent is notice, look, see how the unit on top and the unit on bottom is the same? Then you're doing a percent, okay? As a matter of fact, these units cancel. So if the units are the same high and low, they cancel out. And then when you multiply by 100%, that's why this number now takes on this unit. So it's not 50 questions percent. That's not what we're going to write down here. It's 50% because these units will cancel themselves out, okay? All right, so part divided by whole. That's going to give you a percent. So here's an example. It says calculate the percent of the biomass that makes up the shrub layer. So let's make sure you understand what they're telling you here. They're saying in all these plants, the mass of all these plants is about 20,000 kilojoules per meter squared, okay? For just the trees, this is their biomass. For just the grasses, this is the biomass, and there's for the shrubs, okay? And if you think about it, if you add up those three types of plants that make up all the plants there in that area, it should equal about 20,100, okay? So it says, what percent is the shrub layer? So that number is the part. So we're going to have 5,000, and keep those units, kilojoules per meter squared. So that's the part. It's a smaller number there. Divided by the total, the whole is 20,000. So let's write 20,100 kilojoules per meter squared. Notice my units are going to cancel here. Okay, so we're doing it right. Percent, the units high and low are going to be exactly the same. With rate, no, the units on top are going to be different from the units on the bottom, and the units on the bottom will be some kind of time. Okay, so doing that math, let's see. I should have that math somewhere, but maybe I skipped it. All right, I'm going to plug that in my calculator real quick. Okay, so we have 5,000 divided by 20,000. Oops, 5,000 divided by equals 0.24. We're not done. We need to times it by 100. So therefore, then you can put that in the calculator, 0.24 times 100%, or you also got to know just that you're going to move, there's two zeros there, so you move your decimal over 2 to the right. So it's going to be 24% is our answer. Okay. All right. Now let's do another percent problem. It says, the following table shows the mass of plant matter before and after the plant matter was dried, and that removed all the water. So calculate the percent of the plant's mass that was water, okay? So here's a plant. Plant's made of proteins, carbs, lipids, and nucleic acids, and water, okay? So when we dry the plant, all that water is gone. That plant's going to shrivel up, and there's no water left. All that water is gone, okay? So let's think about this. So this plant, or these plants that we had here, because it looks like there was 10 of them, they were 19.6 grams were their mass. When that water was removed, now they were reduced to 4.2. So if you think about it, the water that left would have been the difference between these. So that would be what left, the water was 15.4 grams. Okay, so if I say what percent is water, so this is the amount that's water, that is the part. So 15.4 grams is going to go on top. The whole was 19.6 grams. Okay, and now we just got to do the math here. So this gives us about 0.786. We're not done because we got to do percent. So you got to times by 100% and or move our decimal over twice. Boom, boom. So this would be 78.6%. So most of plants, it's actually just water. That's why when you dehydrate fruit, you can have a big slice of fruit, and whenever it's done dehydrating, it's really tiny because most of a plant's mass, like fruit especially, is water. Okay, percent change. Not on the formula sheet. You're going to have this one memorized, and it comes up all the time on the AP exam, okay? I think it's an easy one to memorize, though, because we've turned it into a rhyme. It is phi over I. So phi over I. Of course, if it's a percent, you're going to have to times it by 100%, and then that's going to give you your answer here. Okay, so phi over I. So basically, you're going to be given problems. You got to go find what two numbers they want you to use, plug it in, do some simple math. Okay, so we got to read carefully. It says, calculate the percent change in concentration of anthocyanin in apples grown with reflective cover. So let's go right here. Here's anthocyanin. Here's reflective ground cover. Here is a number right here. Okay. Relative to the concentration of anthocyanin in apples grown without, it's this number right here. Okay. Let's think about this. It looks like there's more as you move from here to here. So if I say the percent change, it looks like it goes up. So when I'm done calculating it, I better have a positive number because it's gone up from here to here. If I don't have a positive number, I've done something wrong. So try something else, okay? All right, so I'm going to, now they first talk about this number right here. This one comes first, okay? So we're going to call that's just this first number in our equation. So they mentioned this number first. So I'm going to write 24.10. And here's my units. I know they make no sense to you, but we want to write it in moles. Pretty sure there should be a times there or a dot there. Centimeters, negative squared. Okay. All right. And then my other number was this one. So this one's my initial number. So it used to be this, and now it's up to this. So this is the initial, and now this is the final. Okay. So my initial is 14.51. Same units, animals per centimeter to the negative 2. Okay. All right. Divided by, remember we said this number, this one was my I, this one is my final. Okay. Started at this and then went up to that. So I just need to put that number again at the bottom, 14.51. Here's my units. All right. You're doing percent, right? See how my units, high and low, are all the same? So that's why it's going to cancel out. We're not going to have any units except that percent. So when I do that math, I end up with a 9.59. Write those units again. And divided by my 14.51. Okay, those units are going to cancel. This gives me, move that down here. 0.66 is my answer. Not done. It's a percent. Multiply by 100%, or move my decimal over twice since there's 2 zeros. 66% is my answer. Okay? And then think about it from here to here. So if I double this, okay, that would be about 29, right? And that would be 100% increase if it went from 14 to 28, okay? It didn't go up to 28, it did up to 24. So it's definitely going to be less than 100. That sounds about right. About 66% would take it from 14 up to 24. Okay. All right. And I just realized that I'm not going in order on this one. So you're going to flip back, and I apologize that I skipped around a little bit. But I'm sure you'll be able to find this page in your note packet. All right, so more calculations that are not on the formula sheet. Just note, when they're not on the formula sheet, it's going to be simple math. You're going to be using, addition or subtraction, multiplication, division. You just probably need to go find the right numbers and do some simple math processes, okay? If you see a question where it says, how many times greater, okay? If it says, how many times greater, put the greater number on top. So how many times greater, put the greater on top. If it asked you how many times smaller, you would put the smaller on top, okay? So it says, let's just think about this, okay? It says you make $50 and your friend makes $100. Calculate how many times greater is your friend's earnings to yours. You guys can do that in your head. They make twice as much of you. Now, what that formula is they took the greater number and they put it on top. 100 is what they're making compared to you, which is 50. Now, when you read these problems, this is a very important word. They want your friend's earnings. That line is the 2. So your friend's earnings to yours. So your friend number earning goes on top, and then your earnings go on the bottom, okay? And that's how they got the answer to 2, okay? It's 2 times greater, all right? So now let's apply that to some sciencey questions here. Calculate how many times greater is the rate at 30 degrees Celsius to the rate at 20. I'm not asking you to calculate rate. They've already done that. These are all rates, okay? So I just got to read the table or read the graph. So at 30 degrees, okay? So at 30 degrees, let's call that about 170, okay? So 170 and milliliters of O2 per gram per hour, what that is, okay? 2, and then at 20. Well, that one was easy. It was right there at 80. So 80, there's my units for that 80 number again. Milliliters of O2 per gram per hour. Okay? All right. And that's it. There's no unit. This cancels. So that's why your answer is just like twice. There's no 2 and then dollars. It's not $2. Okay? So when we do this, we see that 170 divided by 80. Let me do that real quick. And that looks about right. 2.125. Okay, so it's going twice as fast at 30 than it is at 20. Okay, and that looks right, makes sense. Okay, notice I just have a fraction. Something to another number. 170 to 80. Okay, I can also call this a ratio. I could say calculate the ratio, or I can write it like this: how many times greater? So let me show you a problem where they're just asking you in a different way. I say calculate the ratio of apples to oranges. You had 6 apples and you had 10 oranges. It would be apples on top, apples to oranges. So it would be 6 apples divided by 10 oranges. So my ratio, it would be 0.6, okay? So it's simple. One number to another, top over another number, okay? All right. Calculate the ratio of the average maximum elongation rate for the modified RNA, blah, 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 blah. So there's a lot of words in here you don't know, but it's a ratio. So you're just going to have a fraction. That's all you got to do. And you got to go find 2 numbers and make sure you have the right one on top, okay? So it says calculate the ratio of the average maximum elongation rate, which is, looks like we're going to pull one of these numbers over here for the modified RNA polymerase compared to the wild strain. To the wild strain. So to the wild strain number is going to go on the bottom. Okay. So here's my wild strain. It looks like it was 12 nucleotides per second. Okay. Compared to this experimental one is what they're basically saying there, which we're going to call that 2 nucleotides per second. And that should give us 1.667. There's no units. What this means is that this is almost, that doesn't seem right. What did we do wrong here? 2 divided by 12. Oh, that's why. Say that didn't seem right. This equals 0.16. Okay. All right. And again, there's no units because they cancel out. All right. Let's talk about conversions, which we actually did a conversion before. I just didn't call it a conversion. So remember this problem over here. I know my pages are out of order. Bear with me. And it was this one. So see how we had in days and then we converted it to a week? It's a conversion. It was pretty simple, right? So don't freak out when we see conversions. But they're not going to tell you to convert. You're going to have to pick up on that. And again, not everyone will. And that's why some people are going to get 3s and some people are going to get 4s and some people are going to get 5s. Okay. This one, you have to go find the right data points using all this complex information that they're showing us here. Okay. So it says calculate the mass in PG. So when I see that, I'm going to start to figure out where is this PG at? And it's right here. Okay. So it looks like I'm getting 0.4 PG per second. That's how I would read these numbers over here. Okay. So PG that would be produced by this reaction in 1 minute at a PEP concentration of 50 micromoles. So I'm going to start finding these labels. Here it is, PEP concentration. There's my units. I got to go find 50. 50 is right here. So I'm just going to kind of mark, okay? And a compound X concentration of 18. Compound X, here it is, 18. My bad eyes, I believe that would be the circles, right? So at 50, here's my circle. All right. So what I figured out is that we are getting 0.35 because that's in the middle. PG per second, right? All this is wanting you to figure out is how much PG we're going to be getting in 1 minute, okay? Most of you then would be able to figure out, oh, there's 60 seconds in a minute. So I just need to take this and multiply it by 60, and that's going to give me my answer here. And let's see here. 0.35 times 60. All right, that gives us 21, okay? Now, you might be wondering, what's my units here? Well, hopefully you can figure it out. It's PG per minute, but I'm going to go ahead and write PG in a minute since we multiplied by 60. Those of you that know stoichiometry, let me just show you how these units are canceling and how you can use stoichiometry and other things outside of chemistry, even biology, right? So think about it. We have 60 seconds in 1 minute. This has to be a true statement that we write here. In 60 seconds, we also have 1 minute, right? Okay, so my units cancel out, high and low. And so then I take that times that, and you can see my units will be PG over minute. So 21 PG over minute. All right, we're done. Sorry, I went out of order. I think you guys are probably smart enough to figure out where to write your notes on your note packet.